Okay, composition of functions. Let's begin here with first talking about what is a composition, which I wrote in the upper right. You will sometimes see this f and then this little circle, f of g of x, or just backwards, g of f of x. Those are can be two different answers there. Most often it is. So order is important. Now, right below each of these in blue, I wrote the way that I prefer to think of these. First thing I do want to point out that it is not equal, okay, this is not equal to f of x multiplied by g of x. When you very first start learning about a composition of functions, we often tend to think of a combination, which we multiply the two, and that is not correct here. Okay. And there's some great examples out there of like, well, what is it? Like, when do we need it? And without going into the formulas, a great example of like how this could be used is, say you had like Fahrenheit. Okay, we had some degrees in Fahrenheit, and we want to get to kelvins, which is used in science, right? A Kelvin, if you're not aware, it's another way of measuring a temperature, which we won't get into the deep understanding of that. Just know it's another form of measurement. We're most familiar with degrees of Fahrenheit and degrees in Celsius, right? So usually we just convert back and forth to here. Well, although there is a direct conversion from Fahrenheit to Kelvin, as I drew in this example, really what it does is it takes Fahrenheit to Celsius and then Celsius to Kelvin, right? So rather than doing a two-step, what a composition does is it leads us from one function straight to an end. It composes two functions. We could think of a first function, we'll call it, whatever, f or g. I'm going to use g and you'll see why in a minute. We'll do a function to go from Fahrenheit to Celsius and then another function Celsius to Kelvin. Okay, that is what a composition is. So it'll I think make more sense with an example. So f of g of x, right? That's what we're going to do first. Part A, f of g of x. And which is equivalent to writing it above right there, right? F circle g and then parenthesis x. So why am I writing it like this? Because then it's a pretty straightforward way of doing these problems. So g of x, I know, right? G of x is x minus 3. So let's go ahead and make that substitution. G of x is x minus 3. But now it says to do f of that. Well, if I said like f of 1, that simply means substitute 1 in for f, right? Or if I said g of 1, substitute 1 in for the x and the g function. So now I'm looking f of x minus 3. So I'm going to take this and plug it in for the x into the f function. So instead of x plus 3, right, I have x minus 3 plus 3. Okay, I substituted x minus 3 into that x. Well, we could simplify this. X minus 3 plus 3 is simply x. All right. Then now let's look at g. I'm sorry, b. So for b, what we're going to do is g of f of x. All right, same procedure here. Let's do a different highlight. I know f of x, right? It's x plus 3. So I'm going to write that in for f, but then it says to take g, right? Look at the g function and substitute x plus 3 in for x. So now I have x plus 3 minus 3. Okay, again, we will get x. Notice, right, this was g, I'm sorry, this, I substituted this x plus 3 in for x on the g function. All right, we get x in both of these. That's a special case. We will talk about that later. It just means they're inverse functions, but again, we'll save that for another day. You don't always get x, and you won't always get the same thing. Now, this one is quite easy for the domains because, all right, there's a special formula and a way to check these, and we can look at that with a more complex example. But here, f of x, no domain restrictions, right? F of x, the domain, the domain is negative infinity to infinity. It's all real numbers. G of x is the same. And when I compose each of these, I could check this. That's all reals, right? And therefore, f of g and g of f both have a domain of all real numbers. I wanted to lead with kind of an easier example and demonstrate how to do the composition. What does it mean? And there's the domain. And in fact, when we look at this next one, probably could have even taken this off the directions for here. I can already tell you in the second example, the domains will be all reals because this, right, all real numbers, this, all real numbers. When we compose the two, whether I'm substituting g of f, g of x into this x, it won't create any fractions or square roots, right? Anytime you're checking domains, two key things to look for. Square roots, or any even power roots, I should say, and then fractions. Okay, numerator and denominator. You got to check the denominator can't be 0. All right. So let's do this second example. Again, I'm going to rewrite this f of g of x because it helps me go directly into, like, what do I need to do, right? Anytime you have something to substitute, do it. I know what g of x is. I'm going to plug that right in. So g of x is 4x minus 3. So I need to substitute that into the f function. Now, another way of looking at these, and why up here when I quickly said g and f, right, it's because usually f of g, we're actually doing the g function first, but we're taking that and we're plugging it into the f function. So I'm taking this g of x and I'm going to substitute it in for x of the f function. But to me, that it starts to confuse me. So I like to write it this way. Just write what I know and now do the problem. Okay, f of 4x minus 3. So substitute this in for x. So now I have 4x minus 3 squared minus 3. Right? I plugged g in for that x. We had x squared minus 3. Now I have 4x minus 3 squared minus 3. Okay. Remember when you FOIL this, you cannot distribute that 2 in. You've got to either write it out or know the formula that you do, 4x squared is 16x squared. And you could kind of see this here, 16x squared. And then we'd have minus 12x and another minus 12x, so that's negative 24x. And then negative 3 squared is a positive 9. So without FOILing, right, without squaring the binomial, you would miss that middle term. It's an easy habit to fall into, bad habit to fall into. Do not square both of those. And it is not 16x squared plus 9. Okay. Now we still have this minus 3. So don't forget about that either. So now we have 16x squared minus 24x and then plus 6. That's all we need to do. Maybe this factors, I don't know. It can't be simplified anyway, so I'm going to leave it. And then as I said with domain, right, f of x had no restriction, g of x had no restriction. F of g of x, we could see here the domain is also negative infinity to infinity. All right, last example. We are going to do g of f of x now. Again, let's go ahead and write f of x. It's x squared minus 3. Okay, x squared minus 3. But then we take that and substitute it into g. Right, we're plugging it in here into that x. So we get 4 multiplied by x squared minus 3, because that's the x. And then still don't forget the minus 3 at the end. That is really easy to forget the rest of the function. You got to write the whole function. This is g, right? There was my x right there. 4x minus 3. All right, this one's a bit easier to simplify. Distribute the 4x squared minus 12 minus 3. So 4x squared minus 15. And like we said, the domain of each of these, I'll just say ditto. It's still all real numbers here. There are no restrictions even as we go throughout this problem. I never add a fraction or a square root.